All right, welcome. So in this video, we're going to talk about TCP flow control. Specifically, we're just going to introduce, just an introduction to the TCP send window and congestion window. We'll see more details about these in later videos. Okay, a little bit of a reminder here. TCP flow control. It's a TCP mechanism that manages the rate of data transmission between the sender and the receiver. This ensures that the sender does not overwhelm that receiver by sending it more data than it can process or that it can buffer. Okay, so in this example here, we have PCB advertising its receive window in every TCP segment. In this case here, it's setting it at 64,000 bytes, telling PCA, don't send me more than 64,000 bytes of data without receiving an acknowledgement from me. Remember, it's got to stop and wait for the acknowledgement. Of course, sliding windows comes into play with all of this as well. All right, so PCA will go, okay, thank you for that. I will create a send window specifically for you. Now I'm going to use your receive window of 64,000 bytes. And I'm also going to use something called a congestion window. Okay, so the send window is the number of bytes that PCA can send to receiver PCB before getting a TCP acknowledgement. That sounds just a lot like just a receive window. Well, we're close. Okay, is the send window on PCA always the same as this receive window? Is it going to be 64,000 bytes? The answer is no. And we're going to talk a little bit about that here, show a little example here in a moment, and a lot more later. But the send window is the minimum of the congestion window, which we're going to talk about here in a moment, and this receive window, okay, that PCB is advertising. The send window is going to be the lesser of those two, lesser of the congestion window. There, I've got it right there. That's what CWND is, congestion window and the receive window. Okay, the receive window, okay, that's just that window advertised by PCB. Okay, what it says, don't send me more than this before getting an acknowledgement from me. The congestion window, that's actually determined by PCA. How does it do that? We'll take a look. Okay, so the receive window, again, we know that's the window size advertised by PCB, determined by PCB. It tells the sender, PCA, how many bytes to send it before getting an acknowledgement from PCB. Okay, that makes sense. We've seen that previously. This is how much data. This is from PCB's perspective, how much data it can handle based on buffer space and processing. Okay, so PCA says, okay, your receive window, that's telling me how much data you, PCB, can handle. What about this congestion window? Well, that's actually determined by the sender, PCA. Okay, PCA is going to create this congestion window. And we're going to see what this is based on is how much data the network can handle. But how much data the network can handle? Well, this is the amount of data that can be sent into the network before receiving an acknowledgement from PCB to avoid congestion. Okay. Well, how does the network play into this? We'll see this a little later here. Okay, but PCA figures this out algorithmically. Okay, how much data the network thinks the network can handle, and we're going to see how it figures that out in later videos. A little bit of an example coming up next. Okay, and it's relying on acknowledgments from PCB. So PCA is it's how much data PCA thinks algorithmically that the network can handle to PCB before getting a TCP acknowledgement from PCB. So what about that send window? Which one is it? Okay, is it the receive window or is it the congestion window? Remember, it's the lesser of the two, whichever one is less. Let's take a look at a simple example. Okay, so we have PCA, PCB here, the initial values. So the advertised window by PCB, its receive window, says 16,000 bytes based on PCB's buffer capacity. This is how much data PCB can handle. It says, don't send me more than 16,000 bytes before getting acknowledgement from me. Once again, sliding window still comes into effect. Okay, now what about that congestion window? Let's have PCA set this at 10,000 bytes. This is based on network conditions, and we're going to see how it does that a little later. But right now, let's say that the network conditions are kind of poor. So what is the send window? The send window is going to be the minimum between this congestion window and the receive window from PCB, whichever one's less is less. So which one's less? Well, let's take a look. The congestion window, what is that? 10,000 bytes. What's the receive window? 16,000 bytes. Okay. So, I'm getting a little ahead of myself here. So we're going to see that the PCA is going to say, you know what? My send window is going to be 10,000 bytes, the lesser of the two. Okay. So this send window, once again, it's the lesser of the congestion window and the receive window. So PCA can send up to 10,000 bytes of data before needing an acknowledgement. It just chooses the lesser of the two values. The one it determined is the congestion window. That's what PCA determines. It happens to be less than PCB's receive window. Okay, so right now it looks like the window side, the send window that PCA is using is based on the congestion window, the smaller of the two. Okay, so PCA starts sending data up to 10,000 bytes before receiving an acknowledgement from B. Okay, and this is the limit imposed by the send window. Okay, it can be dynamically adjusted, and we're going to see this in later videos. Let's say network conditions change. The network conditions are now a little better, as determined by PCA. Okay, so in this case here, let's say the congestion window, because the network conditions are better, is allowing more data to be sent. Okay, so now our congestion window, let's say, is calculated to be 14,000 bytes. Let's take a look at what our send window is. Our send window, congestion window, is 14,000 bytes. Okay, but that receive window is set at 16,000 bytes. Okay, well, the congestion window is still less, but it's actually gone up a little bit, hasn't it? Okay, so now our send window has increased from 10,000 bytes to 14,000 bytes because the congestion window increased. The network conditions got a little better. That's always a good thing. Okay, but let's say PCB, its buffer capacity is decreasing. Okay, and it says, you know what? I can't handle 16,000 bytes. Okay, I need to drop my window size. I'm going to send you a TCP. In every TCP segment, I include my window size, and you're seeing it now changed to 8,000 bytes. All right, let's see what this does to the send window. The send window, again, is the minimum between the congestion window and the receive window. The congestion window is still 14,000 bytes. But look at this receive window that was advertised by PCB. It's now at 8,000 bytes. Now that's the lesser of the two. So guess what? Our send window is now set to the lesser of the two, which is 8,000 bytes. Okay. Now the segments that now PCA can't send any more data than 8,000 bytes before receiving an acknowledgement from PCB. So that's the relationship between the receive window, congestion window, and ultimately the send window. How this is used with more examples is coming in subsequent videos. And what's our next video? And we're going to be seeing this congestion window and receive window Next video we'll be doing is TCP slow start. Hope to see you there.